Let me give a brief introduction about Tiago. I mean, you can all see his bio and profile, but I actually came across Tiago's profile when I started seeing some YouTube feed in my in my AI interest search, and I started seeing a lot of good content that Tiago had been posting on using of AI within OutSystems. So for me, at least, that's how my first interactions with Tiago were. And then during the AI versus agents challenge, we did have a few discussions. I got a couple of good inputs from Tiago as well. We had a good discussion sessions as well. And that's where we discussed whether we can have his expertise during these masterclass sessions, and Tiago has very gracefully accepted not just for one session but for two sessions. So for those who don't, which I'm assuming are very few people who don't know about Tiago, he is an experienced OutSystems architect and an AI agentic architect at HSO. He's been as an OutSystems developer and a mentor, and I believe also an MVP for quite some time now. He started out in the Portuguese Navy, where he served as a naval engineering officer, and eventually brought those skills to IT domain as well. His military background and discipline obviously shows in the level of detail that he goes into his content and the quality of his content, and the ability to be a multi-skilled professional, and the leveraging of AI and low-code development, the amount of content that he's created, the quality of content. I will strongly urge you to go and look at his YouTube videos as well. I'll try and post a link of some of those on the event so you can go and take a look at it. But that has been very pivotal for my agentic AI learning journey as well. So without further ado, Tiago, over to you.
Yeah, thanks, Hugo, and thanks for this warm welcoming. Yeah, it's interesting that you mentioned the Navy part and bringing the soft skills from there, because one of the characteristics that I see, um, that the group of us that need to be more technical, the struggle that we most of the times find with AI is that AI has a more humane behavior. So it's not, we are not talking anymore with machines, with pure machines that we just need to read the API structure, or we just need to read the documentation and that's it. It works, it integrates. We are indeed talking with a different system that is more close to the human behavior, right? And this changed completely the way we developers need to start looking into the use cases, into the way we use agents. And yeah, we could saw that in the agent versus zombies, I think, that we had different people doing different approaches to how to use the agents, and yes, it was a really cool experience. But for today, we are talking about MCP, and so let me start by sharing my screen. Okay, so just to first read a bit about the room. Does anyone here saw my session in one? If so, put it in the chat just for me to know a bit more. If there are people that are going to see this two times or not. Okay, no, I think we are okay. Perfect. So yeah, this is basically, it will be 2 hours, and in this first hour, it will be more going into the theory of MCP, and then the second hour going more into the practical. So that's why I was asking. But yeah, I think we can skip this initial part. Subu already did this amazing introduction. So let me now start with knowledge check. So I will need your help, guys, to put in the chat the answer to the questions that I'm going to make, just to see more or less how the room is in terms of knowledge of AI and MCP. So first question, put in the chat who here knows the difference between an AI model and an AI agent that clearly knows the difference between the two of them. Okay, so far no one. Perfect. Means that it will be good. Then second question, just to check the room, check to see if the chat is working. Who here knows what AI means? So the A and the I. Okay, so who knows? Okay, so, okay, perfect. And third, what is MCP or Model Context Protocol? So who here knows what indeed this is or how it works more in detail? Okay, so we have here Nikhil saying I do. So this means that probably for the ones that know, there will be here some things that probably you will hear it repeatedly, but I believe that other things it will be different. So let's go. And finally, just to double check, who here has already used MCP in OutSystems? All right, so that's the coolest thing because we will learn how to do this today. Okay, perfect. So as I said, this will be 2 hours, and first we will start in the first hour. We will go into the agentic world. So we will specify a bit the difference between AI models and AI agents, and this will be important to understand then the needs and the born of MCP. Why did it appear? And in a more general way or in a more theoretical way, how does it work? But then we will, after that, we will go deep dive a bit into the code of how the MCP works in OutSystems. And we will see both the MCP server and the MCP client. We will talk about that later. And then we will have, in the second part, in the second hour, we will have some demos for you guys to see how we can use MCP in the different layers. Also, we will have between the theoretical part and the practical. So before the demos, we will have like just a short Q&A, and then in the end, another Q&A session. All right, so let's start. Who here knows what this is? Or who here uses this normally on a daily basis or weekly or with quite some recurrence? Probably, I believe that most of you guys here already use this, right? So ChatGPT, really famous. OpenAI was the one that basically opened the world, the generative AI to the world. And the first question that I want to make is ChatGPT an AI model or an AI agent? And the reason why I ask this is that because most of us do not clearly know the difference between the two of them. And here, Pankaj, I don't know if I'm saying correctly the name, sorry, but he already say that it's an AI agent, and he might be correct. So let's explore why. So let's start first with an AI model. So an AI model is basically a closed box with a very complex algorithm, mostly made of neural networks, and can have different layers, different ways of putting together with transformers, with other things. And an AI model is per se a stateless box. He does not have any job in the world. He is simply a piece of code that receives an input. And for example, we put here the sky is, and he, according to his training, he gives an output, blue. The sky is blue. And the reason why he can write or he can do complete sentences is then because we pick that output, we combine with the input, and then we ask again, the sky is blue, and he calculates then the second token. And this is basically how an AI model works. And if you go with this until the end, he will decide somewhere that it is okay. He gives an end token, and we have the complete sentence. And if you guys are curious a bit how these AI models work in a 3D way, this web page, this link that I put it here, it has a 3D animation of how the initial GPTs worked, the nano GPTs and the GPT-2, I think. So you can go there and you can see the complexity that exists behind these AI models. But yes, I will put the link in the chat. Let me just give net dash LLM. Okay. So, but as you guys notice here, the AI model is basically a box without meaning. He does not have any context of the world. He does not know what to do, right? And but he is indeed a box with a very complex neural network. So now let's go and explore the concept of an agent. And the concept of an agent is interesting thing because the concept of an agent does not come from AI. I know that most of you guys are hearing this agent or AI agent in this in 2025, 2024, not so much, but in this year. But the reality is that the concept of an agent comes from the 70s or the 80s, but I think 70s, when there was the introduction of robotic electronics, and we start having like factories with heavy machinery. And so there was this need of creating the concept of the agent. And an agent is an entity that can read from environment, so it has sensors. He can make decisions based on some kind of algorithm, and he can take actions. So if you guys have a piece of code or something in the world that is clearly an entity that can do these three things, according to a multi-agent system, it is considered an agent, right? And why is this important? Because in reality, the only thing that differs an agent of an AI agent is that an AI agent has in the middle the AI model. So you can see that the rest of it is pretty much the same. So an AI agent can also read from the environment, so he can receive inputs from a database, from the user, from a web page if he scrolls on the web, and he can also act upon um, the different types of outputs that he can give. He can give a response, he can act on functions to write on the database, or, for example, run logic. So this is basically the difference between an AI agent and an AI model. And the funny thing is that we can pick this concept and we can compare to something that we already know ourselves. So if we would look into us as an AI agent, the AI model would be basically our brain. And why we say this? Because if we take our brains outside our body, they become useless. They cannot do anything because they cannot have the eyes to give them the images that they need to see from the world. They don't have the ears, they don't have the nose, so they cannot read from the environment. At the same time, they cannot use the body, and they cannot use, for example, the mouth. So they have no way, the brain has no way of giving output to the world, right? So this makes the easiest way for us to differentiate what an AI model is from an AI agent, right? If we look at ourselves, we are agents also, but we are human agents. So in our case, we have in the middle the brain, and then we can have all the sensory around us to read from the environment and to act upon the environment. So this makes basically a world right now where we have three types of agents. We have human agents, we have AI agents, and we have system or machine agents, automation. So going back to the initial question that I put it here, is ChatGPT an AI model or is ChatGPT an AI agent? And as someone said here before, if you guys use currently ChatGPT, you will see that he is not just a simple AI model as it was in the early days, where you would simply talk with him and he would just give you back text. So nowadays, he can search on the web, he can read from sources that you give, read from documents, read from the user, but then he can also act upon it. It's possible for him to generate code and to run the code in the browser for you to see. So he already has a set of tools around him that allows him to be considered indeed an AI agent. So yes, ChatGPT nowadays is an AI agent. But for example, when you hear something like, oh, ChatGPT or OpenAI released ChatGPT 5, this means that they have a new version of the product, and most likely the AI model that exists inside of it, that can be one or it can be even a team of many AI models, will be different. So yeah, this was basically the difference between AI agent and AI model. The reason to why this is important is because right now we will focus more in the concept of AI agents, right? So when mostly the rise of ChatGPT, OpenAI, and people starting to integrate things with AI, there or with AI agents, there was this need to create a sort of a protocol. And let's see why that happened. If you guys are with a friend, right, and you ask that friend if she has any plans for tonight, right, or sorry, for tomorrow, if your friend replies to you something like this, it will be really strange, right? Probably you will think that that person has some problem or is having a stroke. Why is she talking to me in JSON, right? But at the same time, if that person goes to Google Maps and he goes to Google Maps to the search bar, right, and says, "Hey Maps, be a champ and show me the best way to go to Kirkavels Beach." Yeah, oh, Google Maps will not also know what to do, right? Because he is a system. He is expected to have a better structured output, or in this case, input. Why does this happen? Because there is basically a difference between the way we can communicate with ourselves or between the different agents. We, as humans, we tend to have what it's called an unstructured communication. So we don't need to have strict rules on the syntax of how we communicate. We can have grammar rules, each language has that. We can have social rules, but we don't have syntax rules in the communication. It's an open way. The way I'm talking here with you guys, I don't need to follow syntax rules of how I'm talking. I'm just doing it. But with systems is different because systems, they need to have structured communication. That's why when we have APIs, we need always to have a documentation of that API showing for each method what is the input that he is expecting, the output, the format, if it is a date, if it is a number, or if it is a text. So this is one issue that it might appear when we put agents talking with systems, right? Because an agent was trained to talk like us in an unstructured way. So OpenAI, they saw this problem. I think it was even in the early days of 2024, and they tried to solve this, creating what they call the functions. So the functions is a way to allow an agent to convert a certain request into a structured manner. So, for example, in this case, you can see in the text that is here, I created a function to calculate the best route. And I give here a description, and then I say in the properties, it has two attributes. It has the origin that is of type string, and it has the destination that is of type string also. So what I'm doing here is that I'm telling ChatGPT not only, hey, if the user asks how to go from one place to the other, you should not only call this function, but you should also follow these rules. You should give an origin and a destination. And with these functions, it was possible finally to start converting unstructured text into structured text. So in this way, if we, after creating this function, we would go to the chat and we would ask the same thing, he would be able to call the function knowing that he needs to give an origin and a destination. But then something needs to be done, right? Because this is just a language converter or a syntax converter. It converts unstructured to structure, but then we need to have something happening for this to work, right? So this basically meant that every time we would want to integrate an agent with a system, we would have to create a function to do that, but we also had to create all the code to integrate with the APIs of that system, right? So what would happen is that, yeah, I would ask him to do that. He would basically, there was a function that I just talked to call the APIs. So the agent would call that function by detecting that there was that need, right? And then that function would be the one responsible to align with Google Maps. So it would be strictly developed to call the API of Maps and then to get the response and give back the response to the agent. So this means that each time we would have a need to integrate with the system, we would have to create a function, right? So it's cool because it allows to integrate, but it gives here some difficulties in the process. So you guys may see here that for us to integrate just with one system, in this case Google Maps, basically everything needed to be done on our side. So we had to create the agent or use the agent. Most of them are already there, but we would have to create the function, and then we would have to create all the credentials, all the communication to talk with Google side, and we would have to create the APIs and the responses, and then create the functions to reply back to the agent. So this means that if by any chance you have a project with a client that has different agents that need to integrate with different systems, this means that each function that an agent would have to be different depending on what each agent uses. So in terms of scalability and in terms of standardization, this was a hell to maintain, right? Because each agent, we would have to go to each one of the functions that they use, and in each one of them, we would have to give, if it uses Google, let's get the user an API key, sorry, or secret. If he uses Jira, the same thing. Then the second one doesn't use Google, but it uses OutSystems. So it was really hard to maintain, right? And because of this difficulty, Anthropic, most of you can know about Anthropic because of Claude. So it's also one of the biggest AI players in the market. So Anthropic, they noticed this scalability issue, and they decided to create the MCP, or the Model Context Protocol. And this MCP basically is a way for an agent and a system to communicate in the standardized way. And this worked because in their protocol, in their specification, they created two concepts, one for each edge. So they created the MCP client that is part or it's closely attached to the agent, and they created the MCP server that is closely attached to the system. So from now on, please bear with these two um, concepts because we will be talking a lot about them too, the MCP client and the MCP server. Um, and um, and so they created these two, and they said, okay, which protocols can those two use to transport information? And they created different tools and different information to exchange between the two of them. So we'll deep dive a bit more into them, but basically, Anthropic thought, okay, normally, what type of information does servers give to the world, to other servers or to other systems or to users? And they think, okay, normally they share APIs to share functions and features, business or non-business related. They can share files. So if it is, for example, an FTP server that has a set of files that can be shared with the world, and these were basically the two common situations. And so they took this and they said, okay, so the APIs, they are close to the functions that we consider. So let's call them tools. The files, let's call them resources. And then we also have a third one that it's more characteristic of the concept of AI agents, that is the prompts. Because for some systems, it might be handy to give specific instructions to an agent of how he should use this connection with the server. So you can give prompts explaining to the agent, if you are going to connect with me, consider this, or if you want this information, consider using this prompt. So with these three, basically the MCP server can expose everything needed for an agent to integrate with that system. And as I said before, initially they created this protocol using STDIO. So it was a protocol that it's not indeed interesting for web applications because most of them they don't use this concept, but they also created the streamable HTTP. And so in this case, OutSystems already likes it. So it was possible with the streamable HTTP, at least with the HTTP part, not the streamable, but with the HTTP part, it was possible to integrate with OutSystems. So with this, it became now very different the way we could integrate agents with systems, because this means that now it is up for the systems to develop their MCP servers with the rules and with everything that is needed. So this means that all the logic that was on the side of the agents, that we had to know that Google Maps has this API that retrieves this structure and has that API that retrieves that structure, we no longer need that because all those rules are inside the MCP servers. So the MCP servers are the ones that say, we have these functions or these tools and these resources. For this tool, use these rules. So this means that right now, we only need to have each agent integrating with the generic MCP client library. And then after having that, it's just a matter of configuring with very simple steps on the MCP client side saying, I want to connect to this MCP server and to this and to this. And the protocol does the rest. So this means that comparing now the same scenario, but using MCP, right? This means that when the agent is initialized. So even before us talking with an agent, for example, when you open the agent page, when you start a session, he initializes a communication with the MCP client. And then the MCP client knows, oh, I have configured in my way, in my system, that I need to communicate with the MCP server of Google Maps. So because it is a protocol, it already follows standardized procedures. So what happens is that the MCP client says to the MCP server, hey, I'm initializing. The MCP server says, perfect. These are the capabilities that I have. I have these prompts. I have these resources. I have these tools. The MCP client says, perfect. Give me the tools that you have. The MCP server says, these are the tools that I have. And then the MCP client stays with the knowledge on his side with that information and gives to the agent the list of capabilities that the agent can use. So just before we start talking with the agent, he already knows that he can use these capabilities. So this means that now when the user says, hey chat, be a champ and show me the best way to go to Carcavelos beach, now the agent knows that, okay, I have this calculate best route tool from the MCP server. So he says to the MCP client, hey, fetch this tool. The MCP client asks the MCP server for that information. He replies, and he replies back to the agent. And he just says what happens. And the first thing that you guys might notice is that, but yeah, this is basically the same flow that you showed with the other scenario, right? Where there was not the MCP. So we had a piece of code, the function that would call the API of Google. And you are absolutely correct. It has exactly the same amount of steps. But this means that right now, with having this scenario here, this MCP client is always the same. We don't need to change anything into this code because this is a library that already exists. So we just need to put this library connected to the agent. So we can have 10 different agents. Each agent will connect to different systems in a different way, but all of them will use the same MCP client library. So this means that you can scale to as many agents and as many systems integrations you have, that the code will be always more or less the same. You just need to change configurations. Okay, so this is why the MCP brings an acceleration in terms of scaling agents with systems. So this is basically the MCP. So I want now to take the opportunity to go more into the OutSystems side. I know we have here a question, but after showing the part of the code, we will do a Q&A session, so then we can check afterwards. So let's see how this thing it's called MCP, how does it work in reality? Because one thing is for us to talk in theory, another thing is to really show how to use this. So if you guys go to the Forge, you have here this MCP server application. And you might already notice that it's not MCP, it's MCP server. And the reason for that is because you might remember that if we have an MCP protocol between an agent and between a system, we will have a communication between an MCP client and an MCP server. So this already says which type of system or agent you are considering implementing. Because if you are doing an application for OutSystems and you want this application to be visible for other agents in the world, this means that you are an MCP server because you are exposing the capabilities. But if you are creating an agent, an AI agent, using, for example, Workbench, if you are creating an agent in your side of OutSystems and you want this agent to be able to connect to Google Maps, for example, this means that you will be an MCP client, right? And so it is important to distinguish these two because it depends on if we are exposing or consuming, just like in APIs, right? So in this case, let's start with the MCP. So if we have the MCP server and we install that, we will basically have this application. And in this application, it's basically made, let's wake up the dev environment that always needs some seconds to wake up. So if we have MCP servers, my opinion is that we should not have very big MCP servers with a lot of tools and with a lot of resources to give, because just remember that you will be giving to an agent the tools and the resources you have. So this means that if you have an MCP server with 100 tools and with 100 resources, it will be really hard for an agent to manage all that knowledge, right? It's just like us. If someone gives us a book with 100 functions that we can call in our work, it will be really hard for us to memorize all those 100 functions, right? So this means that, in my opinion, when we are developing MCP capabilities in our systems, we should divide them in different MCP servers depending on the use cases. For example, if we have already a domain-driven design in the client that we are working or in our project, so if we are already working with a domain-driven design, it's a good opportunity to also do a domain-driven MCP server. So each domain will have its own MCP. Or if you are exposing different capabilities to different types of clients, for example, if you have functions for internal clients and other functions for external clients or for end users or for companies, B2B, B2C, you should also separate this because there will be different nature of agents talking. So we have here the MCP the MCP app where we can create as many MCP servers we want. And if we go inside in one of them, for example, let's go inside the MCP1. Exactly. So in this one, we are saying that in this server, we have tools. In the tools, we have these two tools. We have the get employee information and we have the list employees. And I don't know if this has this has, because this was more recently made, but it is here. So if we go inside the tool, we need to specify the name of the tool. We need to say the description, or we need to give a description. It's important because this is how the agent will know when he should call this tool. And we need to give a schema. And this is really important. This needs to be, for now, it needs to be manual, because you need to know, you need to tell the agent which parameters, inputs, does he need to give. For example, to get an employee information, he needs to give an employee ID, right? And how can the agent know the employee ID? Because there is another tool to list the employees. And you might see this as a similar pattern if we would have an app with the HR, right? We would have a list screen that we would see the list of all employees, and then we would click in a specific employee and we would go to the detail page that basically opens with the ID of that employee. So in here we have the same thing. We have a tool to list all the employees, and then we have another tool to get a specific employee information, right? So this was an example to show how we can define an MCP server. And in this case, we will also use more in the demos this OP MCP. So OP is the personal AI agent that I've been working on, exploring more edge cases. So this OP MCP, in this case, it's a bit different scenario, but basically he has the tool, and this tool is called call maintenance agent. So what I'm doing is that I'm using MCP in a wrong way, but for now it's how OutSystems allows to do it. But we are calling another agent by using this tool. So this means that if an agent wants to talk with the maintenance agent of my business, he can call this tool and he will pass a message, a session ID to maintain the conversation flowing. And with this, the two agents will be able to have a conversation. So this was basically how the MCP server works. How was I able to create this protocol? First, because Anthropic has a website where it specifies really well everything that is needed to create an MCP server in terms of rules. And of course, if we go here to the documentation, we see that they explain everything really well. And then there is here the build an MCP server. And I was really happy. I came here ready to start building the MCP server. And then I saw that, of course, it needs to be code. It doesn't have OutSystems. It makes sense, right? Because almost any library in the world has here an OutSystems with the orange balls showing how we should do it, right? So yeah, it had this code, and I saw, okay, I cannot go from here. I need to deep dive into the specification. So in this specification, you guys can start seeing here the server features. You can, for example, see the transports or the authorization, how it should work. By the way, we can use a normal authentication with an API key. And then if we go here to the server, we then have the way of how we can implement the different calls. And to simplify a bit this is really close to APIs, the way we do it, with a small difference that make a huge difference in OutSystems side. Basically, we have for prompts, we have two types of messages. We can ask, hey, give me the list of prompts that you have, or we can have, give me the prompt. And this is the same for the three types, prompts, resources, and tools. For each one of these three, you have basically two requests. You have the list, basically give me the ones you have, and you have the call, that is, give me that specific one, right? And for each one of them, we have a response. And you may notice that all the responses have, or sorry, all the requests have these three, and then this, right? And if I go to the resources, we have the same tree, and then this part is different. And the same thing with the requesting. We have these three. If we go to the tools, here they are. We have the same tree, and then this part changes. And a very important thing that you guys might notice here is that this request, the structure of this request is not generic for every tool, right? Because you might remember that when we are specifying tools, we need to specify the inputs that the tool has. So this means that each tool will have a different structure. In this case, if we want to call the tool getWeather, we need to give inside the arguments the structure location. But if we wanted the calculate route that I talked before, we would have to give an origin and a destination. So for the ones that probably already start noticing the issue here, is that we have a protocol that, depending on the tool that we are asking, it will have a different structure. So how can we handle in OutSystems receiving inputs from an API that, depending on the business logic, the tool that we are asking, the JSON will be different? How can we serialize something that it changes on runtime, so to say? So this was a challenge when implementing the MCP server. So let's see how it goes. I just wanted to show you guys this website because it explains everything about MCP, how you can call things, what are the rules. But now let's go inside the code. We have here our MCP server, right? So we have the screens. And if we go here to the logic, we have the MCP here. And you may say, oh, wow, there is only two. Perfect. So this is really easy to implement. Yes, if we are considering just the two of them, yes, that's really easy. But then we have this monstrosity. And the reason why we have this monstrosity is indeed because we are receiving text. You see here? We are receiving text. And why are we receiving text? Because if each API will have a different structure depending on the tool that it's being called, right? If I would pass here a fixed structure, basically this would break the API, or OutSystems would not consider some information. If we would only pass the common attributes, right, being those common attributes, the JSON RPC, the ID, so this it always exists. So if we would just consider these, it would work, but all the rest that is dynamic, OutSystems would simply discard it. So the only way to make this work was to use text. So OutSystems always gets the full text, and then we need to work the JSON in a different way. In this case, I use the transform from Ardo, I think it's called Ardo, from our colleague, no, Jason Nata, sorry, the Ardo was another one. Jason Nata from our friend Nathan, sorry, Stefan, Nathan, here, no, Stefan. So he created this library here, where basically it allows us to work with JSON in a text form and then do operations in that JSON, asking for the attributes and so on. So with this, it's possible to pick a generic JSON and start deep diving into the different structures after that. And in here, of course, these 4 knights here, they are just basically the different exception codes that the protocol demands of having. Each one of the exceptions, they need to have a specific error code and a specific structure. So again, we need to handle them in this way. But let's now go into what we are doing. So every time we receive a message, we are receiving in this request. Why do we have this initialize SSE? This is a very important limitation. If we go to the forge component, you will see that below here we have these limitations. And we see here that basically, due to the limitations of OutSystems, it's not possible to use SSE. And what is SSE, or Server Sent Events? SSE is a way for us to stream inside an API. So right now, what happens is that OutSystems uses a normal REST API protocol, meaning that when we call an API, we initialize the session, we do the handshakes, we say, I'm this system, I want to communicate this API with you, the other system verifies the authentication, we create a handshake, and after the two systems are aligned, I send what I need, he replies with what I need, and we close the connection. This is how an API works. With SSE, what we are saying is, instead of closing the connection immediately after the response, the connection stays open. So we do the same procedure of, hello, I'm the system, I want to communicate with you. The other system says, okay, perfect, handshake was made, and the connection remains open. So this means that I will send something, he will reply, then I can send again a reply to him, to his reply, and so on. And we can do this in a streamed way. OutSystems currently does not allow to have this scenario. And in O11, it was possible by using extensions to create this SSE on an extension side of it. But with ODC, the way the architecture of ODC works, is not possible for you to have an SSE communication. So this means that I basically had to create this initialize SSE because in the protocol, this needs to exist. We need to be able to say to an agent that we don't have this capability. So basically, what I created was I've created this initialize SSE that basically responds saying that it's not here, it's not available in the server. So this is basically just a method to reply to the agent, no can do. So we can just go with simple HTTP. So yeah, you can see that the only thing we do is this request. Everything comes to this request method, and the only thing that he receives is the server name. Because you guys might remember that we have the capability of creating different servers, and they will be recognized by their names. So we first validate if the structure, the common structure on the top is correct, if it has the JSON RCP and the ID and so on. Then we validate if the server really exists. Then we check the token because it needs to have a token to communicate, a simple API key. And then we check, is this an initialized method or not? And the reason for that is because you guys remember when in the slides, when I showed that when you start the session with the agent, the first thing that he does is to say to the MCP client, I'm initializing, and then the MCP client says to the server, I'm initializing. So this initialization is a way for an MCP client to create a session with the MCP server. So this is how they create a bond for that session to switch information, call tools, list them, etc. So this means that every communication after they initialized, they need to have an MCP session ID, and this is a header information. You can see here the header. So this means that in the initialized, there is no need of the MCP session because we are initializing, but then afterwards, it's always necessary to have a valid MCP session. So this validate session checks if the session is a valid session. And then we start doing the transformation. So we fetch the dynamic parameters because they can be different. And then we start basically identifying the different types of requests that we can have. So we can have an initialize, we can have a prompt list, a prompt get, a resource list, a resource read, a tools list, and a tools call. So basically, do you remember that I said for those three different types, we have the two, we have to ask them for the list, and then we have the call. So these are the 6 types of information. And for each one of them, we deserialize the text, we then call the respective logic, and then we fetch the result. So this is basically the main structure of this system. And I don't want to deep dive much more than this. This was more just for you guys to understand why there is this complexity here. But I do want to talk of a very specific one, the tools. Because the tools, we need to have a way of easily connecting the tools with the logic of other applications, right? Because we will not put all the business logic that we want to expose in this generic MCP server application. We want to have other applications somewhere in the environment that have this, that calls this tool. So if we go here inside, we see that after doing some validations, if the tool exists, and then we want to go to the part where we call the tool, then we have this basically way that I saw that it was the most dynamic way to implement and to scale this with many tools. So what we do here is that we create this concept of an internal API, that the internal API will always have the same name. So it always has the name internal MCP, and then it has the same name of the function. So if we go here to the MCP server, we have the OP here. So the name of the function is call maintenance agent. So, and the tool, or this tool, yeah, it is in this application with this API key just to protect. But why do we need these two? Because these two will be combined in the URL of the internal API. So if we go here to the code, we can see that we are calling the app name and calling the function name. And why does this work? Because then if we go indeed to the application where we have the exposed API, you see that we are using the same name of the function. And so this works because OutSystems then calls this logic. So this is how we basically scale the functions inside OutSystems to call the different applications in the business, because we might have 10 different applications with tools to expose to agents. So this was basically the way we can use an MCP server, and you can fetch the resource from the Forge and start using. But OutSystems also offered us in one of the latest features of the Agent Workbench, they also offered us to connect to external MCP servers. And now pay attention, because we are now shifting from the MCP server to the MCP client. So you guys already saw that it's possible with this application to create MCP servers in OutSystems, so to expose tools, right? But there is also the need, depending on the use cases, for us to be an MCP client to fetch information from other systems, right? And so OutSystems allows now to do this by using, the connections in the portal. So if you go to the connections, you may see that now we can connect to an external MCP server. So this means that we are an MCP client. So yes, let's try to do this. If I want to communicate with an MCP server, I need to put a name. And yeah, I know this might seem a bit of an inception, but let's simulate that we are connecting with our own MCP server that I created, right? So I have the OPMCP. I don't need to put for now a description, but let's consider that we have here the URL. Let me just fetch the URL. Okay. Okay, so it is an API key. Let me